Okay, so this is our review for heats of reaction number 1 and 2, and we'll go ahead and go through and I'll give you answers to a few of the problems and kind of explain them. So we're going to be doing delta H. Anytime you do delta H, it's always in energy per mole. So joules per mole, kcals per mole, kilojoules per mole, etc., etc. Okay, so the very first problem says delta H for this equation is how many joules per mole of hydrogen. Anytime we see per, that always means divide. So what we're going to do, we're going to find our energy, and it's right here, 285. And then we're going to go ahead and find our moles, and it's going to be our coefficient of our balanced equation. So what we're going to do is we're going to take our 285 joules that we've got from the equation, and we're going to divide it by our 2 moles of hydrogen. Okay, and that's because that's what the problem asks for. And then that's going to give us our 142.5. Now, it's going to be a negative value because anytime you have the energy that's on the opposite side of the moles, that means it's an exothermic reaction. It's giving off energy. So negative 142.5 joules per mole. So you do the same thing with oxygen. Take the 285 and divide it by, but only divide it by 1 mole. So it's negative 285 for that one. And then for water, it's going to be the same thing, 285 but divided by 2 moles. So 142.5, but positive value. It's on the same side. Okay, another problem. Let's go ahead and work on inserting an energy term into the equation. It says delta H reaction is negative 31.2 kcals per mole of hydrogen. HCl. So HCl is on the left side. So that negative side means it's going to be on the opposite side. So it's going to go on the right side. We're going to put a plus, the energy. Now that's per mole of HCl, or another way of saying it, per 1 mole of HCl. But in the equation we have 2. Okay, so it's going to be double that in the equation. So it's going to be 62.4 kcals on the right side. And we don't need the negative side because it's already showing in the equation it's on the opposite side for that. And then in 3b, it says if 3 moles of HCl react. Well, we know if 2 moles react, it's 62.4. Okay, so what we can do is we can use our delta H up here. We can use that as a conversion factor. So we're going to start with our 3 moles that they ask us about of HCl, and we're going to do a dimensional analysis. Okay, in the delta H, it's 1 mole of HCl. Okay, because it's implied if they don't say how many moles, it's just 1 mole, is negative 31.2 kcals. And that's how we're going to do our setup. Moles of HCl cancel out. So we're just going to triple that. Okay, you do the same thing in 3C, except for we need to make one for MgCl2. So that was pretty easy because the ratio is 1 MgCl2 per 62.4 kcals. So your conversion factor is going to be 62.4 kcals per 1 mole of MgCl2. It's going to be a positive value. Okay, and then in number 5, it says 108 grams of aluminum and 35 kcals of energy is released. Okay, so again, delta H is going to be energy per mole, or kcals per mole in this problem. So we're going to divide 35 kcals by 108, but we need to convert that into moles. So we're just going to convert 108 grams of aluminum to moles and then divide 35 by that. Okay, and then we're going to go ahead and insert it. Number 6 says insert in the equation below. So we're going to need to balance that equation first and then go ahead and insert it into the proper side. Okay, so the key here is energy is released. So it's going to be somewhere on the right side. And we're going to have to decide if the coefficient, for example, of aluminum is 2, well, then we would need to double that term. If it's 3, triple it, so on and so forth. Okay, so down here at the bottom, in the notes, I gave you this, but this is just step by step. Okay, so write the balanced chemical equation. So magnesium is burned. So magnesium plus, remember, oxygen, so O2, and that reacts to form magnesium oxide. Magnesium has a 2+, oxygen has a 2-, so we need one of each. Then you got to write it. All right, done. Calculate the amount of energy released by the magnesium. So really that's where our Q equals equation comes in. Okay, so it's just going to be Q equals Cp of water times the grams of water times the change in temperature of the water. Everything is of the water. That's by definition of a calorimetry problem. Then we just need to convert grams to moles, 5.5 grams. Okay, convert that into moles. Need the molar mass of aluminum down there on the bottom. And then number 4 is pretty simple. It says convert your answer from number 2 because it gives you it in calories. We need to go ahead and convert it into kcals. So we're going to move our decimal 3 times to the left. Okay, and then finally the last step down here, it just says find the molar heat of reaction. And so really all we're going to do, it tells us what to do. Remember how often the formula tells us what to do. We're going to take our kcals, okay, that we found in problem number 4. Okay, so right here, our kcals, and we're going to divide it by our moles that we found in problem number 3. Okay. All right, I gave you guys some help on that. Good luck with that.